Sleep is the secret to storing memories. During deep sleep, fast and slow brain waves sync just right, scientists say. And when those brain waves sync, our minds ferret away memories for us to return to later. That memory-saving brain wave syncing happens hundreds of times a night in young adults. But in older adults, the process begins to break down, according to University of California, Berkeley researchers in a new study published in the journal Neuron. The researchers found that, as we get older, fast-moving electrical bursts called spindles fail to coincide with the slower brain waves. The mistiming prevents older people from being able to effectively hit the save button on new memories, leading to overnight forgetting rather than remembering, said Matthew Walker, a University of California Berkeley professor of neuroscience and psychology and author of the study. Sign up today for a free 30-day free trial of unlimited digital access. The researchers also identified the part of the brain where they believe our nighttime memory storing process goes haywire. It's the medial frontal cortex, which is the part of the brain's frontal lobe that creates the kind of deep, rejuvenating sleep that young people tend to enjoy and that helps us lock in memories for good, according to the researchers. The worse the atrophy in this brain region of older adults, the more uncoordinated and poorly timed are their deep sleep brain waves, Walker said. But there is a silver lining: sleep is now a new target for potential therapeutic intervention. The study analyzed 20 young adults and 32 adults in their 60s or 70s. Before sending the participants to bed, researchers asked them to memorize 120 pairs of words and then tested them on it. Next, as the old and young participants slept, the researchers watched their brain activity. What the brain activity revealed was that, in the older participants, the fast-moving spindles often peaked early in the memory consolidation cycle, missing their opportunity to sync up with the slower waves, researchers said. And other brain scans showed there was gray matter atrophy in the older study participants' medial frontal cortexes, researchers said, implying that front lobe deterioration is keeping the slower waves from staying in lockstep with the faster spindles. The finding is a significant step forward, according to at least one researcher unaffiliated with the study. This is the first paper that actually found a cellular mechanism that might be affected during aging and therefore be responsible for a lack of memory consolidation during sleep, Julie Sabt, a lecturer in sleep and plasticity at the University of Surrey in the UK, told NPR. The researchers also said their study points to possible solutions for older adults to improve memory. By electrically boosting these nighttime brain waves, Walker said, we hope to restore some degree of healthy deep sleep in the elderly and those with dementia, and in doing so, salvage aspects of their learning and memory.